I would like to ask you this question. How long have us been trying to use crypto from ancient time? You may have heard about Caesar encryption, and that is where the foundation of cryptography has laid from Caesar time. So, but compared to cryptography, AI is a much modern technology, newer to us. When we talk about attacks against AI, we know that we have some input going to some model, small or large, it doesn't matter. A model is trained, and the main goal is to do inference. We know that it is important to keep the assets of the model intact. We want to respect the cost of training put into this model, but there are multiple attacks. You may have heard about side-channel attacks, where some observables can leak information about the weights of the model. You may have heard about fault attacks. The same result can be observed, extracting the construction of the model or the weight of the models. There are many different types of attacks. If you attended yesterday presentation, there were information about sabotage attack, and that is called backdoor attacks. For years, we have seen many types of backdoors, like adversarial examples, hardware Trojan, software Trojan. They are all coming under the same umbrella, backdoor attacks. Are they new to us? Didn't we see examples of this attack before as cryptographers? We have seen that. And because of that, people have been devising private and secure function evaluation. If I want to bring it now to the domain of AI, it would look like two parties would like to do something, some computation, using a trained model. As a user, I don't want my data be leaking to the other party. So I want to keep it private. What I can use is using secure function evaluation within the multi-party computation, for instance. Now, as an IP owner, I don't want the user to extract information from my model. What I can do is using function evaluation, secure and private function evaluation, again, within the multi-party computation. And perhaps you have heard about this fancy word, fully homomorphic encryption, computing on encrypted data. That can be also done within the context of AI. It is a bit costly compared to the other cases in multi-party computation, but it is doable. I was thinking about the attacks. Side-channel attack, fault attack, backdoors. Are they possible in this case where everything is encrypted? In the first case, user data is encrypted. In the second case, user data and the model is encrypted. Like the third one, they are still possible. So if I use a laser fault attack, it is still possible to extract some information about user data, even if it is encrypted and used within the multi-party computation. What about side-channel attack? If I listen to the chip, even computing on encrypted data, it could be possible to extract weights of the model when used against an encrypted user data. So it is quite scary, right? But there are methods. You can see there are cases where even these physical attacks can be stopped if we use the right cryptographic approach. It is costly, definitely, compared to what you can see, but it is scalable. If one tells you it is not scalable, it is too costly, reconsider talking to that person. Now, let's go back to another question. Can we verify the computation? Can I say that this is my own NVIDIA chip running the same computation that the user promised to do? It is definitely possible. So our team is part of the FlexHack, let's say, builder group, and in that we have been proposing new techniques brought completely from the crypto approaches. In that we have a verifier AI processor And the idea is that if the verifier says, I'm just doing inference on images, I want to classify if it's a dog and cat, then the AI processor would say, this is the proof, some back and forth between those two, and finally the secure processor would say, okay, I'm convinced you are really doing classification on the images. You can see that many messages are going on. However, you can make it much cost-effective. Sending just one message between those two parties, you can send short messages from the AI engine to keep it with the right performance metric that you have in mind, and you can make it zero knowledge proof in the sense that when the verifier receives information from the AI engine, no information about user data may leak. So this can be done, and it is part of our job to show it to you. Perhaps next time when we meet, I will have a demo to show that to you. Thank you. If you have interest in this work, please contact us. You can see all information here. Thanks for all the patience.